Hi everyone, my name is Jackie Chen, Solutions Marketing Manager in Max Storage domain. I've been working in Huawei for over 10 years, from R&D engineer to sales manager, most focusing on HPC storage solution. Today, I'm glad to share our thoughts on next generation high performance data analytics or HPDA storage, and introducing our flagship distributed storage OceanStor Pacific. Before I jump to my topic, I will provide a brief update to our company, since I guess a lot of audience may be interested in. Huawei is a leading global provider of ICT infrastructure and smart devices. We are committed to bringing digital to every person, home, and organization for a fully connected, intelligent world. Employees number till now is close to 200,000, over 50 of which are R&D employees. Last year, we were ranked globally number 3 in R&D investment and number 49 on Global 500. Thanks to continuous R&D investment, we have built a full stack infrastructure solution for HPC. We focus on the development of IT infrastructure and professional services in HPC. By working with our industry partners, we offer a variety of professional solutions for customers across different industries. And today, I'm going to introduce our HPC storage solution to you. It is no secret that HPC is playing a critical role in our society. It has become an important driving force for societal progress. For example, we can use HPC to accelerate drug screening, greatly shorten the R&D periods of new medicines. Another example is from genome sequencing. It took 13 years to fully complete the whole genome sequencing at the beginning. But with the help of HPC, we have shortened the time to just 1 day. In recent years, HPC has become even more closely integrated with big data and AI. Data is becoming more and more important. And we see the trend of HPC evolving from computing intensive to data intensive. Let's take a look at the HPC market growth rate on the right. It shows that the data intensive HPC market, including HPDA and AI-based HPC, are growing much faster than traditional HPC market. And we found the workloads of data intensive HPC have similar storage requirement. As we can see here, industries get a lot of benefit from using HPDA and AI technologies. However, this doesn't come without new challenges. There may be a lot of challenges to the storage system. The top 3 challenges we see are as follows. First, the new technology and applications dramatically increase data volumes, like testing car generate 60 terabyte data per day for L4 autonomous driving. Oil exploration applications upgrade from 2D to 3D mode. Data generates 10 times more than before. Most of the data are so important that they have to be stored over decades. Ever-growing data volumes will bring bigger challenges to HPC infrastructure with uncertain situation on planning and expansion, such as not enough footprint in data center, more complex data lifecycle management, unpredictable scaling on capacity and performance for budget applying. The second challenge comes from supporting hybrid workloads. For traditional applications, they often involve multiple processing phases. These phases usually have different I/O behaviors. I will take oil and gas exploration as an example. Seismic data processing requires high bandwidth, while seismic data interpretation needs high IOPS. Normally, two different storage systems are required to host these two types of workloads. On the other hand, for emergent applications, they cause tremendous growth in diversified computing powers, such as GPU, NPU, and FPGA. This further increased the challenge of diversified workload support in same storage system. Third, the diversity of data access protocol makes multiple data copying, which hinders the efficiency of HPC. Let's take autonomous driving as an example. The development process involves multiple phases, such as data injection, data pre-processing, model training, and simulation. There are diversified data access protocol interfaces being used in those phases. For example, road testing data injecting from S3 protocol, handling by bit data with HDFS, and result data for simulation or training by NFS. Meaning, you have to copy huge volume of data to multiple storage systems and waste a lot of time on wasting. But time is very important to the end-to-end development process. We heard a lot of complaints from our customer for this situation. So what's the storage solution for overcoming these challenges in the trend of data-intensive HPC? The answer is our flagship distributed storage, OceanStor Pacific. Huawei OceanStor Pacific is a distributed scale-out storage system designed for support organizations, business, and mission-critical HPDA workloads across multiple protocols simultaneously. As next-generation system designed for data-intensive HPC, especially for HPDA, we believe these three features play a key role. First, multiple protocol interworking tremendously reduce the copying across different analytical procedures, much improving efficiency. Second, hybrid workload-oriented design allows different workload applications running in the same system, reducing complexity of management. Third, high-density design releases space in your data center. You know that in HPC, density is very important. Let's go through the key features with more details. First, the architecture of OceanStor Pacific is aiming at data lake infrastructure for unstructured data. In design level, we create a new metadata system supporting both file and object, so that one copy of data could be read or written through different access protocols, such as NFS, SMB, HDFS, and S3. Besides reducing copying, higher analytical efficiency also comes from native protocol feature supports. When we talk about multiple protocol interworking, we really means there's no loss in both semantics and performance. You can see in the right table, comparing to other vendors, our solution has no gateway and could support native advanced features of different protocols, like object versioning and QoS at the same time. Next, as we know that management complexity comes from storage proliferation. High bandwidth and high IOPS in one system is always like a cake. You could not eat it and have it at the same time. Different workloads require multiple standalone storage systems, and proliferation starts. The OceanStor Pacific Parallel File System is designed to optimize I/O metadata placement, keeping it close to the data on the nodes that own it. I/O processing and capacity management are likewise optimized using large I/O pass-through to bypass cache when appropriate. And granularity specified layout that increase bandwidth for large block I/O streams, while decreasing latency and I/O amplification for small block I/O. In this way, the system supports both bandwidth intensive and IOPS intensive workloads. Meanwhile, a lot of MPI I/O applications require high single stream performance. As we know, the performance bottleneck is from NFS protocol. We put it as an option to install DPC for getting extreme high performance. DPC, or Distributed Parallel Client, is a private agency installing in the hosts. In our labs, we have tested single stream performance with DPC. Comparing to other vendors' solution, we found the performance with our DPC reach 8 GB per second, 4 times higher than that running with NFS. Last but not the least, we do think high density matters in HPDA, which will release space in your data center for the huge data volume growth. Our high density hardware include 2 models. First, high density performance node, OceanStor Pacific 9950. A 5 usages, house 8 nodes with maximum 80 pieces of half-palm NVMe SSD disks, providing 160 GB per second and 200,000 IOPS. Second, high density capacity node, OceanStor Pacific 9550. A 5 usages house 120 pieces of 3.5 inches SATA disks, providing 1.68 petabyte raw capacity. On the right picture, as you could see, the high density performance node has best density performance comparing to the other vendors, about 30% higher than the second best one. And the density capacity of our capacity node is 2.7 times than the general purpose high density server solution. After introducing the key features of OceanStor Pacific for HPDA, let's take a brief look at the use case over the world. Norway Lundin Energy is the largest independent European oil exploration and production company. We help them build a new storage platform for deep sea exploration. With hybrid workload support and tiering between cold and hot data, TCO reduced 35%. Sarikas, the research institute in Shanghai, China, built a HPDA platform with our distributed storage. With multiple protocol interworking and hybrid workload support, the analytics efficiency improved over 200%. At the end, I'd like to recommend you to read the ESG technical review for OceanStor Pacific. After ESG strictly tested the performance and features on OceanStor Pacific, they recommended OceanStor Pacific as the next-gen storage system designed for HPDA. You could get the technical review paper by Google it with keywords ESG, OceanStor, Pacific. That's all for my sharing. Thank you.